Hi, this is going to be part 5 of the programming of Throw Rock in depth. It's taken me a lot longer to unpack all of this than I expected, and I kind of need to wrap it up because it's like what I've covered and what I haven't is slipping through my fingers, and I'm hoping I won't repeat myself too much here. I think, from what I just reviewed, we had gone through everything that game screen does, which is sort of the interface between the player and the game logic on screen during the game. But then there is this game state object. Yeah, okay, so right, there's intro.json. I'll just leave that open. That's fine. So game state would be the core block of logic, well, one of a few, the main core block of logic that determines how the game runs itself. So there's the reset tile map, the entity tile map, the working tile map, I guess this would be. The level properties, a callback to call when a turn has passed, list of entities, reference to the player. So this is where a lot of the logic is. It's kind of split between game state and entity player, I believe. So let's look at game state and see what's in it. So it starts at initialization, right? Yeah, so copy the floor tile map, and I think I went over all of this before. Make sure it has a player after parsing through. Yeah, we totally looked at how this was done. So the interesting stuff is going to be here in update tick. Is this called by game screen? It is if the wait button is pushed. Yeah, only if the wait button is pushed. I believe entity player will also call it yes. So either the player will receive some input, and they'll do something or stop receiving input in some cases, do something in relation to it, and then tell the game state to advance a turn. Or game screen will receive the input of player wants to wait and tell the game state to advance. So when a wait happens, let's look first at what that looks like. So for every entity, if something has happened during the turn that has marked one to be inactive, so basically like, say, a flying rock reached the end of its flight path and turned into a rock on the ground, I think it deletes the flying rock entity and then puts a new entity rock on the ground, so the entity flying rock would have been marked for removal. This is kind of just a little array management trick so that I don't have... If I'm doing something with like a for loop like this somewhere is doing something with every entity and then takes an action that causes one to be removed from the list, then this index would potentially be wrong because I compact the rest of the elements in the array downwards. Except I don't, because I just mark them for dealing with later at a known time. So in update tick, this is when I remove the inactive ones from the array. Just so I don't have to think about it elsewhere, because that could cause subtle bugs if indexes are changing at a weird time. So just this just categorically removes that problem by only ever... this isn't cleaning up the list yet. So if something's not marked for removal, then I call update on it. Whoa. Oh no. Here's a ridiculous bug. So player's update tick gets called once per entity in the... So this should be down here, by the way. Oh, I guess that's not harmful. So what does player's update tick do, just out of curiosity? Nothing. It just sets something to... Well, one thing. Okay, so this variable got set to false a whole lot before that change. Okay. So harmless bug, but could have been a problem if this did repeatable work. Okay? Yeah, so I just put that inside the for loop instead of outside. Okay, so it should be outside. Anyway, so every update, every entity gets a function called on it, which I can choose to implement, however, for whichever entity needs to do stuff. I think flying rock is the only one that actually does anything interesting. This is just a matter of... my controls for, how is it? Like, okay, remind me. Let's launch this thing. So I just picked up rock. I'm holding the button, I press left, and then I can throw it. But if a turn goes by, then I haven't just picked up the rock. Anyway, that variable is used in some way for, and right, there's a preference for whether to use that behavior or not. This is used in some way for fine-tuning the controls, and if a turn has gone by, I know that I didn't pick up a rock that turn. And if I'm holding, then it won't throw something. Anyway, so update all entities, update the player. Right, so what entities exist? There's entity scroll. This doesn't even implement update tick. Entity rock doesn't need to do anything when it's just sitting on the ground. And yeah, the only other entities are player and flying rock. So only flying rock has an interesting thing in its update tick. Sure, we can look at that. So if there are rocks in flight, they will try to move if they have distance remaining. Oh boy, okay, so this is actually kind of the main... Let's actually finish going through this function first before we look at that. So rocks will try to fly. We'll do that in a second. Right here's where the array compacting happens. So this is the number of items I've removed from the array, which is used for compacting it. So I start at index 0, and if I have removed any already, I set the index I'm looking at to where it was previously. If I find one marked for removal, I free its memory and reduce my total count, increase the offset by 1, which means that every entity beyond the one that I'm disposing here will get shifted left by 1 more than it was already getting shifted, which started at 0. And then I decrease this iterator variable so that I'll next look at the one that just got shifted to the left. Anyway, yeah, so this is just a common pattern for compacting a one-dimensional array when I would remove elements from the middle of it. It's reasonably efficient about it. Anyway, yeah, and then if there's a callback here, which there always would be, I could omit this if I was using like the game state object in other contexts or like running unit tests on it or something. Do I have unit tests for game state? Do I have unit tests for anything in Throw Rock? I'm not finding the key I'm looking for. I have not implemented any unit tests. Okay, yeah, but anyway. So it'll just always call the update tick callback. What does that do? Update tick callback. Right, resets the moused over tile, does interpolation stuff. So we looked at this before as an undo node, sure. Okay, so what you'd expect. All right, and that's all of game state update tick, except the interesting stuff in entity flying rock. So I guess I haven't shown how a rock gets put into flight yet, but at some point it will. We'll go over that in a moment. But anyway, so when entity flying rock exists in the world, and it's being updated, no, I do need to show how that starts existing first. Okay, so we'll come back to this. The other ways the turn can advance are when a player receives an input and decides to do it. So now hang on. Oh boy, this is complicated to unravel. Okay, so I'm going to try and cover everything that can happen in a turn before I look at the other stuff, which, yeah, all of that is relevant. Okay, so this is kind of a tangle between 3 different objects that all interact with each other. Yeah, so I think the next sensible place to go is going to be the player. So when an action is taken, the player will get either a start input call or a stop input call for whatever axis is moving. So axis X, move direction negative, just says you're going left. X positive, you're going right. Y negative, what coordinate system do I use? Okay, so negative Y in this coordinate system means up. Positive Y in this coordinate system means down. And then there's also an action axis, just because I have sort of this tricky system where all of those move inputs are encoded into a single integer, and I use bitwise arithmetic to operate on them. Just for handy compact storage. This is just part of my library functions that, again, was not invented for Throw Rock, but was very handy to use here. So I can just say to permute this, this is typedef to uint32 or something. I think it's 32, it might be 64. Anyway, so some number of bits saying whether you're holding like on the x-axis, holding left, if you're holding right, and which of those was more recent so that it can interpret what to do. So anyway, what am I looking for? Right, so let's say I start an input of move left on the player. I guess I would go to start input. All right, so this is the function that permutes the move, the move input state. I could show what that looks like. Very briefly, that'll be game math, I believe. Move input. So what function was I calling? Move input start. Okay, yeah, complicated bit math and stuff. I guess it's... You know what? Let's not get into this. It's an API that keeps track of... Well, actually, now I am curious what that's typed F to. How many bits did I give that? It is an unsigned int. No, that's access. It's a uint32. Okay, so 32 bits of move input state, and that just determines how many access values you can encode in that single integer. So you'd use an additional move input if you need more, etc. Anyway, so I encode whatever has changed with the axis and direction into my movement tracking variable. And then if it's the x or the y-axis, so we're moving somewhere on the field, or trying to, and a change has been made, so this isn't like a key repeat, I guess, or like you're holding the left arrow key and you also press left on your gamepad or something. When would this be false? There are cases, yeah. I think that would be a case for that. Last move axis. I wonder what I use that for. Yeah, so here's this most recent direction thing. So move input has encoded in its bits somehow which direction was most recently pressed. And axis is not last move axis. Return false. What does this mean? Let me play with the way my movement works. So if I'm gonna, what's a nice wide open level? Wait doesn't have much open space. Rock vault doesn't have much. Interrupt has a bit. So I'm gonna hold left. Whoa, jeez, okay. Ooh! Why that not update? Oh! I think I found a bug. If I get this at the right time... It's not until I release the key that it decides to update the visuals of that. I think I understand why. Okay, want to take a detour and fix a bug? No, not yet. Maybe later. Okay, so if I'm holding down and then I start holding left, it switches my movement to left. If I'm holding down, I press left and release left, it keeps moving down. I think all of this is logic to make all that feel nice. So I spent a long time tweaking the way that the player moves around, and also built on the foundation of that raccoon adventure game that I showed once a while back. That was where I really started refining these concepts. Anyway, yeah, so like player movement is a good place to spend a lot of development time because it's really important to get right, and the game feel is like all in how the movement works. Anyway, yeah, so I do a lot of trickery to make sure that movement does what you'd expect with the inputs that you make. And like it's very easy to set up a movement system that does stuff like, for example, like if I start holding down and then hold up, oh, that's probably not what I want. Oh, well, I didn't spend enough time on that. Okay, so I can move back and forth like that. What I would have expected to happen was while I'm holding up, I would move just up. Then when I release up, I would move back down. Turns out it's not working the way I thought it did. Okay. I think the key repeats are like overriding something. Okay, so anyway. Movement's complicated. There are more tweaks I can make. So that bug, that redraw bug, I try not to redraw the screen when something hasn't changed, and I think it doesn't acknowledge that something changed when the, oh, I can't recompile this right now. Never mind. Anyway, yeah. So key repeating against a switch would need to, let's see, what is it? Call redisplay or something. Let's see. How is... Yeah, okay, so this will be here in needs redisplay. Sorry, needs redraw. Well, this will never be true. No, it doesn't need to return from here. Redisplay. Resume callback, level select callback. Anyway, I just need to call shell redisplay somewhere when that happens. Well, surely this returns true when I input that, right? Or is that an action repeat? Yeah, action repeat. Entity player, start input. Or is it not the input? It's the... Okay. Somewhere in here, this is returning false when it should return true. When it bumps into a switch but hasn't actually made a move. Okay, so I need the ability to recompile the game, and like my library is in a state of refactoring, and this is, I'm not currently SVN updating this code on this computer just so we have like some stability while looking at this. So unfortunately I can't fix that bug right now. If I would try to compile the game, well, have I updated anything on this computer? I mean, I can try this, but I suspect this will just fail. It won't overwrite the executable I'm running there right away. Maybe this is fine. I don't know what the state of my stuff is. It looks like that compiled. Okay, maybe I can do this. So I compiled it. I will have fixed that one bug that didn't actually do anything. Okay, I can compile it right now. That's fine. Let's try and debug that. That might be hard. Let's try just returning true from here. That will potentially redraw the screen more than necessary, but it will tell me if that is the false that needs to return true. I could look at that more closely, but there are only a few to change, and it might be easier just to... Did I build the release build? That is not the current date, so no, I want the debug build, I guess. I think I have release builds disabled right now. That is the current date and time. All right, so that was interrupt. That didn't do it. Okay, so it's a different one of these. Let's try and actually figure out why that is. It will be from start input, right? Like start input will continue to be called on game screen during action repeat. So yeah, move axis X, move direction negative, entity player. If changed, okay, so if not changed, right, it won't have changed because I'm just moving in one direction. So this is saying if I'm moving on both the X and Y axis at the same time, and the axis is not that axis. Ah, so this has to do with diagonal motion. Let's see what that looks like. Ah, okay, so it just does not diagonal. If I'm holding two, like, so I'm holding down and left right now, but it refuses to diagonal. So it just continues with whichever one was going. Okay, sure. So, yeah, so it just ignores... It ignores inputs on the one that was not the most recent so that diagonals don't happen. Okay, sure, that's fair. So then, right, so this definitely wouldn't have been the thing to change. Move input to direction. Right, so this is just an enumeration that's left, right, up, down, or something, right? Share definitions or something. Entity direction. None, west, north, east, south. Okay, I have a direction of none. Sometimes that's necessary, I guess. Yeah, so that just converts the axis and sign to an enumeration value. Okay, so if we are currently throwing, yeah, so if the throw button is held, hang on. So if we are currently throwing and the throw button is held, right, there could be cases where the throw button is held and you're not currently throwing. Could there be cases where you're currently throwing and the throw button is not held? I don't think so. Anyway, but if both of those are true, and this is a new input, then, right, if we're already throwing in, yeah, so this is the logic of canceling a throw. If we're already throwing in that direction, so we're holding the throw button, throw is established to be, let's say, left, and I'm pressing left again, then it says throw direction is none, so that's how you cancel the throw. And the throw has been canceled, therefore I'm not putting down a rock when I release the action button after having pressed it while holding a rock. Anyway. Otherwise, I update my facing. Right, the player knows which way it's facing at all times, even though that's not drawn or has any impact on the game logic, but it's still tracked there, just in case. Anyway, yeah, so there is a variable that knows which way the player is facing, and it does update when you choose which way to throw. So it'd be mostly just a matter of adding 4 different facing sprites, and I could show what that is, and it'd just be purely visual. Anyway, throw direction, that's the more important one. That's the one that determines where the rock goes. Entity direction. Okay. So it's not in here that I need to make a change. If move player, self, entity direction, blah, facing is entity direction, update tick, return true. Well, that should do it, probably. I assume this returns... Oh, does this return true if I bump a switch? This might be interesting. Entity direction to vector 2i. Right, yeah, so once again, just changing the enumeration to a 2 values plus minus 1 or not on the x and y axis. Okay, so move player. So when player wants to move, it calls this function here. Entity player offset. Last position is that. New position is current position added with offset added. So this will always be, the x and y axis of this will always be -1, 0, or 1. And it should always be just one of those. So x or y will be one of those values. The other one will be 0, because it only moves orthogonally. Okay. If you're going off the edge, right, so if you've managed to touch an edge of the map, then I tell game state about that. Right, and this I set variables still to be able to interpolate off the edge. Game state, level edge touched. Sure, let's see what that does. Game state, level edge touched. Play the secret complete sound effect, level complete, secret exit is true, and then game screen handles the rest of animation and level transitioning for that. Okay, so this has a pretty simple job here. And then you just stop because you touch the edge, and it needs to like suspend further processing so you can just exit and get to the secret level. Okay, so check which tile you are touching. So game states, tile maps, tiles at the math to get the 2-dimensional coordinate into a 1-dimensional index, because this is a flat array that just wraps around at edges. Tile map width plus x, right, okay, so get the tile's properties, tile property bits. So that will be in, whoa. Is it tiles, tile list? Okay, so get tile properties, tile property bits. Right, so it can have a solid floor, it can stop the player, it can stop a rock, and it can be elevated. Any overlapping or non-overlapping set of those. So that's a bit field of basically behavior of the tile that you're getting. That's just to avoid having to query like a list of all the types of tiles. I can just abstractly say, this tile has this behavior, and handle it here. And somewhere in here there's a big list of those, tile list. Yeah, so this is just macro defines to say that tile ID 1 is grass. This is like draw priority, I think, and has a solid floor. Wall stops player and stops rock. Player, that would never actually apply. So rock stops nothing, is not a floor of its own. Right, neither of these would both be in the like higher layer of tiles, so those shouldn't show up. But I give them properties anyway. Yeah, so water has no solid floor, doesn't Shouldn't that stop player? Wait, water doesn't stops player? Water should stops player, shouldn't it? Maybe water is handled specially so I can play the other sound for trying to walk onto it, but it doesn't have the stops player property, and I check for that to bump. What do I do in response to that exactly? Ah, okay, so there are two different ways to stop the player. So I guess basically like is solid to player, but then if no solid player, player just doesn't want to, refuses to walk on it. So this would be pit and water and I think nothing else probably. Something without stops player, but also without solid floor or something. Anyway. Okay, so if it's a solid wall that I'm bumping into, which would be the case for the, oh, yeah, check it out. This is going to return false. Okay, I think I see how this is. I don't think I see any harm in returning true from right here, right? Causes an update, facing equals that. Yeah, so I don't want to call update here. What I want to do instead is to just return true. Right? I'm pretty sure, because I want to do that logic back out there. And this else becomes redundant because it won't go past this line if that if is true. So this should fix that bug, right? So you return true to say that a state has changed and you should continue with what you're doing, including set up to redisplay the thing. So first of all, okay, so nothing weird when I bump into the wall. Interrupt. There, I fixed it. That's better. Okay. Interesting. So I guess before the visual state just didn't update until that was released, or this is only on future repetitions or something? It's weird that that worked before with this behavior as it was, but anyway, that's a fix. Okay, cool. Yeah, so it specifically checks for red or blue switch. Because those are the only things that are solid that I can bump into that have a special behavior. This is a little janky. I should probably have GameState tell me whether what I bumped made a state change or something. Anyway, so if I'm bumping into something that has the stops player property, then I call GameState entity bump tile. So this can do further processing. GameState, there you are. Entity bumped tile. Okay, so get the tile ID at the bumped location. Right, that's the position that was bumped. Here's the entity that bumped it. If it is switch blue, play the sound effect and call the toggle function. If it's switch red, play the other sound effect because they have different ones and call the toggle function. If it is ice barrier and it's a flying rock and the flying rock has the fire element, then sure, we got to melt that ice. Set the tile map at that position to grass and remove the flying rock entity because the fire rock just dies. It doesn't turn into a regular rock. The ice consumes it. If it's a cracked wall and it's any rock, then break that wall and turn the wall into grass, but don't remove the rock because a rock hitting a cracked wall survives. Okay, so this toggle red-blue switch gets called. Okay, so toggle. Yeah, okay, so it's very simple. Just iterates through every row, every column, looks at the tile map at that position. If it's blue gate down, then change it to blue gate up. If it's blue gate up, change it to blue gate down, correspondingly for red. And if it's the switch, then just change to the other type of switch. There's sort of some potential here for, I think I could place both a red switch and a blue switch in the tile editor with like different states and get them out of sync, and they would just like keep on toggling. I guess just like for aesthetics, I always place them with the same color because yeah, this would just toggle between them and maintain that non-parity of color if it were to be in that situation, I think. So I just choose when I set down the tile state, which is which. Anyway, so and I think I also choose like what means open and what means close. Because like you could have a blue switch with an open blue thing, a blue switch with a closed blue thing. Anyway, so yeah, so essentially there's actually no difference between red and blue. They're just visual so that if you see a blue one, you know all of the blue ones will be in that same state. And if you see a red one, all the red ones will be in that same state. And that blue is the opposite state from red. But that's actually just a convention. There's nothing here safeguarding from violating that convention and having like both up and down red gates simultaneously and both blue and red switches simultaneously. Anyway, yeah, but the convention is a convention and just toggles there. Okay, so that's all that happens when any entity bumps any tile. There's not a lot of bumping behavior. Right, yeah, and this happens whether the entity that bumped it was a player or a rock. Okay. So if that happens, right, play the bump sound effect. If I don't want this to play at the same time as the red-blue switch, and there's nothing else the player bumps that needs to return true from there, right? Because player bumping this does nothing, player bumping this does nothing. Okay, so this covers all the cases. It looks a little messy, but it does cover all the cases, so it'll work fine. Okay, so then I'm walking into something that's not solid, but is not walkable. Sound effect move? No, I'm not doing that. I'm walking into something that is walkable. The other one is here, sound effect move fail. So that's the name of the thing that plays when I try to walk over water or a pit. Okay, so sound effect move, position equals new position. So the move succeeded. And I tell the game state that I left the tile I was standing on and that I moved to the tile that I will be standing on. So entity moved from tile, entity moved to tile. So that'll do stuff like drop trapdoors if you're holding a rock. And that might be the only thing. No, it'll also be pressure plates. Okay, so entity moved from tile. So check what type of tile it was that was moved from. If it is plate down, and this is an entity which holds pressure plates, it could be a flying rock, but in this case it's a player and does hold pressure plates. Yeah, so holds pressure plates is a virtual function on the player which just returns true. Flying rock will return false. Is flying. No, by default it returns false, so this just doesn't override that at all. Is flying. What? Okay, so that means something. Entity rock returns true from holds pressure plates. Yeah, so entity, what is it? Game entity? Game entity is default implementation for holds pressure plates is false. So yeah, flying rock just doesn't change that. So where was I? Holds pressure plates, sure. Game state, entity moved from tile. Okay, so if you are a thing that holds pressure plates and you're leaving a pressure plate that is currently down, it better be down because you're leaving it and you were on it, check for any other entities that exist on that plate. And if you find one that does hold pressure plates, you know, something that's not a flying rock, then stop what you're doing because your processing is finished. The plate doesn't need to pop up. But if you don't find something else that holds that plate, then the last thing that holds the plate had just vacated it. So play the plate release sound, set the plate to the up sprite, and do this other kind of toggle. So toggle elements connected to plate, self, position, false. So toggle elements connected to plate. Yeah, so this will toggle down or up. Okay, so it looks through all the properties, gets the plate wiring at that position, all of the instances of plate wiring at that position. And then iterates through their targets. Yeah, so again, like the position 14.8 has the wiring of toggle 16.8. Position of 18.3 has the wiring both of toggle 13.3 and toggle 11.3. 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 So right, get the position that is being toggled. Check the tile ID there. If it is gate down, and the pressed matches the toggle mode in such a way that its state needs to change, so there's like a bunch of logic packed into here, then set it to the up tile. And I guess just which tile ID it is determines whether it's solid or not. So by changing this variable, it changes the solidity. And then just the opposite here. Yeah, so if it is toggle or the wire mode is open and it is being pressed, or the wire mode is close and it is not being pressed, then I set it to down, and just the opposite here. Open and not pressed, close and pressed, open and pressed, close and not pressed, but always for toggle. Okay, so I think that all makes sense. Right, so entity moved from tile. Right, and that's all the pressure plate processing that happens. This is nice and compact. I love how small this is. And there's not that much to it. It's a bit of boilerplate for like getting the level properties. But yeah, I like that this all fits in one page. Nice and simple for how to toggle things. Okay, so if it's a trapdoor and you are a player that is moving and you have a rock currently, then, trapdoor over pit. So I guess trapdoor over pit is just trapdoor. This is like the draw DNA here. Right, that's just called a trapdoor. This is called trapdoor over water. So trapdoor over pit gets the pit trapdoor sound, changes into pit. Right, and if there are any entities there, which would include scrolls and rocks, and they are not flying, so it would not include flying rocks, then that entity gets removed. And right, entities falling don't get their own sound. It's all just included in the trapdoor falling. Right, but I could do a separate sound effect. I'd want to coalesce them so it only played the fall sound once per, even if a bunch of things were dropped. I guess a bunch of things being dropped would mean you'd have to have a trapdoor with a scroll and a stationary rock on it. Anyway, right, this is the same sort of... Ooh. How does game state get entity at position work? I think this is correct. Yeah, okay, so this is kind of an abstracted iterator. So I can just say whatever entity is at this position at this search index. So if I call this repeatedly with index increasing, it will perform the search every time, but then will only return when I've reached the index that I'm looking for. Anyway, it does what it sounds like it should do. And right, if it's marked for removal, then that just doesn't count as an index at that position. Okay, so anyway, we were on entity moved from tile. Yeah, okay, so remove entities that are on a trapdoor that fell. Same thing for water. This is identical code except for minor differences. This is going to be trapdoor water instead of trapdoor pit. The different tile ID changes to water instead of pit. I guess I could totally have packed these into a function because that's definitely identical, but I did not. Okay, but those are the same thing. Okay, cool. So then when the player moves to the new tile, there is token activation that happens. Sure. Okay, so player, if you are a player and you're stepping on an active fire token, deactivate that fire token and set it to inactive. Ice token active, set to inactive, play the sound. Yeah, so these are all the same for deactivating. For activating, if it's inactive, set it to active, play the sound, so that's all the same. If it's a plate that is not down, and you are something that holds pressure plates that's moving there, press the plate, set it to plate down, toggle elements connected to plate with true. Okay? If it's an unlit torch, okay, yeah, so this is not applicable to the player. This is for flying rocks. So if a flying rock is moving onto an unlit torch and the rock's element is currently fire, then that torch gets lit. Well, we'll play the sound effect for lighting the torch, and the torch gets lit. Right. And if the torch is lit and you are a rock with the wind element, then the torch gets extinguished and the torch becomes unlit. Yeah, sorry, we play the extinguished sound and extinguish the torch. Now, the handling for the torch affecting the rock's element is separate. I think the rock does that itself. But as far as game state is concerned, that's what happens when a rock contacts a torch of either type. Yeah, so that handling is going to be split between game state and entity flying rock. So we'll get to that. So this doesn't like reach out and change the rock's element. The rock chooses to change its own element because it sees it's going over a torch. Okay, and then if this is the goal and you are the player going over it, what do you mean hack? Huh. Okay, apparently I wasn't happy with this logic. Just checking if the current level index is the last level index. And you play all levels complete instead of level complete. I mean, all the ways I'm playing sound here are kind of non-ideal. Like, this would be better as a pure state object that doesn't do stuff like sound effects, and it should do an event dispatch for something else that would turn events into sounds. Just because then this object wouldn't have a dependency on my sound playing system, and I could like unit test it without like having it try to play a bunch of sounds. Or I could give it an interface that has a play sound function. That's probably actually the way to go. Yeah, that'd be better than an event dispatch. Would it? Kind of. I don't know. Yeah, I'm not entirely happy with having sound logic intermixed with core game logic, because usually visual and aural stuff is like, that's view logic, and that should be kept separate from core game logic. But here it was just quicker and easier to intermingle them, and it works for the use case. But you know, in a project that I had more than a week to work on, I would definitely do this part differently. Anyway, yeah. So play all levels complete, or level complete if this is not the last level. And set the level complete to true, and then the rest of this, as we've seen, is handled by game screen. Okay. Then entity move to tile. So if you are a player, regardless of what tile you move to... right. So I check if there is an overlapping scroll entity at the position the player just moved to and play the sound effects. This doesn't have anything to do with putting the text up. That's handled separately. But I just play the sound effect on, like, newly stepped on scrolls. Okay, so this is literally just sound effect logic here. No game state changing. Okay, so anyway. So that's what happens when a player moves. Is that everything that happens when a player moves? Yes, it is. Okay, cool. So that wasn't too hard to unpack. Yeah, I'm pretty happy with all that code except for the way game state plays sound. Everything else there, I think, is pretty much as it ought to be. Gives me that feeling of code that works the way it ought to work. Right, so if the move succeeded in such a way that needs to update the game state, then I tell the game state to update. All right. And I guess if the move didn't succeed, then I set the facing. So this would be like, if you're facing south, there's a wall to your right. If you're facing south, there's a wall to your east, and you tap the wall to the east, then you face that wall. But this doesn't have any bearing on anything. Okay. However, if your input that's started is not a move, but instead is the action input, and you have a rock, and that is a change, so you're not like holding the action button on your keyboard and also pressing it on your controller, I guess. Then a throw operation starts. The throw operation has not yet been canceled. The direction, however, has not yet been assigned. And you have not just picked up a rock. I wonder why I do this. I think this is probably unnecessary, but maybe I had a reason. Okay. So right, you have a rock, you're preparing to throw it, set all the variables accordingly, and stop processing further. Otherwise, you don't have a rock. I scan through the entities, right, using this same function that we just looked at. Scan through the entities, see if one of them is a rock. If it is, play the pickup sound. Yes, a player is also participating in the sound effect calls. That's fine. It could be better, but it's fine as it is. There's no way for picking up a rock to fail, so you pick it up, has rock is true. If pick up and throw control preferences are set, then you are starting a throw operation. Regardless, Right, change the graphic to the one with the little gray circle in the middle. Remove the rock entity. Right, rocks are entities, not tiles on the ground. That's weird. I guess there's a reason that this needs to be true for update tick, and then update tick sets it to false. Right, because that calls, we just looked at this, player update tick just picked up rock false. Why does GameState update tick need to know this? Does GameState ever read this variable? Oops, that is not the button I wanted to press. That was spell check or something. So this never checks just picked up rock, but I guess it... Okay, so update tick. It does update the player. And updates the entities. I feel like that line there is probably unnecessary. Maybe it's just for clean state management in case in the future I was going to have GameState check whether the player just picked up the rock, because that would say the wrong thing if I didn't set it. I'm not sure why I added that line. It doesn't seem like it serves a purpose, but anyway. So if we are not pressing an input and instead are releasing it, then I call move input stop, which again is a bitwise permutation. Just, whoa, don't do that. It just changes the integer to whatever, clears the bit of that direction on that axis. It doesn't care if the move input is released. That just stops continuous movement. But if it is the action button that was released, and you hadn't pressed the keyboard, pressed your gamepad, released the keyboard, and then this was not the place where you release the gamepad button for action, is how this would be false when this is true, I guess. And you have a rock and you are throwing it. So you're done throwing. We're going to complete that throw operation here. If you haven't picked a direction, then right, this is just all the logic of like when the rock throws or sets down and when it doesn't. Oh boy, so if you haven't canceled the throw, so like hold the button, press the same direction twice, release the button, which is a no operation, and you haven't just picked up that rock in the same turn, then, and there is space to put the thing down. Okay, yeah. So I check if there's space. So this is the case where we're trying to put down a rock. Iterate through the entities. See if there is a rock already on the ground or you're trying to place it. And interpret that as if you're trying to pick up the rock and fail that. So that's why this is pick up fail, not drop fail. Right, so nothing happens if you're holding a rock and you try to drop a rock on a rock. And then just stop further processing. Okay, so if we're dropping a rock and there's nothing in the way of doing that, put down is one word here for some reason. Pick up is one word too. Okay, that's what I decided to do. Don't have a rock anymore because you just put it down. You don't have the gray inner circle anymore. You're just player. And add a rock on the ground. So this actually creates a rock entity and tells the game state to add it. And then that consumes a turn, so tick the update. Okay? Otherwise, if we're not putting down, we've established a throw direction, then we're actually throwing that rock. Okay, so the throw rock action is here. Don't have the rock anymore. Don't have the gray outline anymore. Create a flying rock with no element, because you can never establish an element just from the player's throw. That's done by other means. We're throwing in that. Okay, so from this position, in this direction, with no element, at a constant throw distance, which is probably defined by, is that shared definitions? Very important constant. Yeah, this did change once in development. I think initially this was 5 and I changed it to 6 because that felt better for some reason. Anyway, yeah, so rocks always throw by 6, but that can be elongated with a mechanic, and then just pass the game state. Okay, so here, right, so add the flying rock, update the game state. All right, so here, control transfers basically from the player to the entity flying rock. So this is the only time this exists anywhere in the code. Player throws rock and creates a flying rock, I'm pretty sure. So on your creation, just passes that to init. So on your init, you choose the tile ID for the element you're initialized with. So I don't think this ever is set to anything other than none, but the code here could handle if I were spawning a fire rock in like the first turn that it exists, or an ice rock or a wind rock. Okay, your direction is that, your element is this, your distance remaining is that. So I could also spawn a rock at a different throw distance. This code would support that, but there's just nothing that calls it that way. Okay, so then, flying rock. When it gets updated by game state update tick in here, we can finally cover what that does. Update tick. So here's the other third of the game logic, basically. Right, so if you have some distance remaining, then you try to move in that direction. Entity direction to vector 2i, same thing as the player used, so you have the direction established from the initial throw, and you try to go one tile in that direction. Entity direction to vector 2i, where is that? Is that like shared definitions? Yeah, here we go, just a simple switch statement. 0, 0, 1, 0, negative 1, 0, 0, negative 1, 1, 0, 0, 1. That's all. 0, 0, if you somehow have memory garbage in there, that's none of these expected values. Entity flying rock, that's where I was. Okay, yeah, so trying to move in that direction if you are currently flying. If you're not, there's more logic here, but currently we are flying. So very similar to move player, I probably copied and pasted and then changed it. Yeah, so if this is going off the edge of the map, then the rock is lost. The rock takes a vacation to the secret level, and you never get it back. Entity moved from tile, of course, so it does leave the edge tile that it went away from. Remove own entity, and then just stop. Okay. So if we're not going off the edge, check what tile is at the position we are trying to move to. I got to check this first in case this would be out of bounds, because I'd just be accessing memory garbage, like out of bounds of this array if I didn't check it first. Loud thing outside. So tile properties. Right, check the tile properties if it stops a rock. And we're not also trying to play a switch or ice melt sound. Okay, so this is getting a little tricky with whether it plays the bump sound effect or not. Yeah, this logic would be better handled by a dedicated sound effect processor that would know things like this. Like if you're trying to play rock bump and any of the sounds that result from this at the same time, it would just skip the rock bump. Yeah, that'd be a better way to structure this code. This is a little hacky here, but it works. Then you have no more distance remaining. Your flight has concluded because you're ready to fall on the ground. You bumped something. And then entity bumped tile, right? So that'll do like the toggle action of the switch or the melt action of the ice barrier in game state. That will not advance the turn. It's only player that does that. That's just something that happens during a turn. So if this tile doesn't stop a rock, then I know I can successfully move, right? Yes, but I might also need to do other stuff. So position equals new position. So I've successfully moved it because that tile doesn't stop the rock. And I don't care about floor support because I'm flying. Entity moved from tile, entity moved to tile. Yeah, from the old one to the new one. If you're flying over a fire token that is active and you are not currently fiery, then become fiery, set your graphic appropriately, and play the fire sound. Same with ice, same with wind, and when you become windy, okay, I'm trying to think if there's ever a case. I don't think there is. I'm just noticing that when I only increase the flight distance, which is the extra thing this does when it becomes windy, if it's not already windy. Okay, so the case where this would apply, I just set this to 1,000. This is effectively infinity, but I didn't want to actually put infinity in there, just a large number that will never be exhausted. If I created a level that was more than 1,000 wide, and a rock traveled across a wind token, and then a second one, and then flew for 1,000 blocks, you would not get the additional flight from the second wind token. But that's irrelevant because there's no way it can lose distance remaining without it being set to 0 after it has gained it. Well, other than just consuming it one at a time. Okay, so this is fine, but the logic is a little iffy, just logically thinking. But, for all the cases where it'll be used, it's fine. So anyway, and if it's a lit torch, right, the torch is the complicated one to interact with here. If I am icy, then I move one step to none. If I am windy, then I also lose my windiness, but not the distance remaining. Yeah, so it continues flying even though you lose the wind element, so you can't put out 2 torches with the same wind rock throw. Not that that ever comes up in the game, but it could. Otherwise, if I'm not fiery, then I become fiery. All right, sure. And then update the graphic appropriately. Okay, so that's simple enough. Sure. And is that everything? I think that's everything, right? No. We took a detour to move, but this does other stuff in update after the move. So if something that I've done has resulted in me being deleted, then I'm going to stop processing. That something would be going off the edge of the level, or... How do I fall in a pit? Okay, so pit processing is here. It's not game state that reaches out and deletes rocks that fall in pits. Rocks decide when they fall in a pit and delete themselves. Yeah, so this is just if I've hit an ice barrier and I am fiery, I guess. Anyway, yeah, so if I'm landing this turn, check for entities on the ground, specifically rock entities. If there is one, then this rock gets deleted. It is the rock in flight that is lost, not the one on the ground. Not that it matters, but that's the way around that it is. Floor was solid, right, because of the interaction with ice floors. So I need to know before I do this processing whether the floor was solid. Get tile properties at the position where I'm landing and solid floor. I tell the game state that I landed on that tile, right, and only flying rocks can land, so we haven't actually looked at this function yet. Game state, entity landed on tile. So entity landed on tile. If it is water and it's a flying rock and it is an icy flying rock, then that water becomes ice floor. And you play the freeze sound effect. If it's grass and it's a flying ice rock, and it's not at the player's position because the player doesn't allow this to happen, yeah, I actually added this. There was an earlier version of this game where this check wasn't in place and you could put an ice barrier where the player was standing. But anyway, this was a change after 1.0.0. Tile map tiles equals tile ID ice barrier. And there was a way to make that happen in, was it not Sanctum? What's that secret level called? It's not Fortress. What's that called? The one, Ice Keep, right. Yeah, so before this little trapdoor jog was there, it was possible to throw... Actually, no, it's possible to do here now. So player moves first, then rock lands, and it doesn't create an ice barrier there. Yeah, because if I had stayed where I was, it would have. Yeah, anyway, so that's the handling for that. And if it is an ice floor, and I am fiery, and again, the player is not standing there, I think it was Frozen Lake where that could have triggered. Maybe one other place too. Then change it to water and play the ice melt sound. Yeah, so that one got real weird. Actually, both of these are weird because a player would be inside something solid or standing on something they couldn't stand on if that check wasn't in place. So I decided to handle that just by not making the state change to the ground if the player is exactly there. Okay, so that's all that entity landed on tile does. So then I remove the flying rock entity. If I was landing on a solid... If I was not landing on a solid floor... And this isn't an ice floor... I know, logic's a little weird here, but like, the rock needs to consume itself when... No, this is all just sound effect logic. Oh, it's not. And also it returns. Anyway, yeah. So this is just handling all the stuff for like flying ice rock, creating ice out of water needs to delete itself without playing the rock lost sound. Yeah, that's all this is saying. If I am ice and this is an ice barrier, I can infer that I have created it just now and I don't want to do any further processing. If I am fire and this is water, I can infer that I just melted an ice floor and I don't want to do any further processing. Otherwise, play the land sound and create a non-flying rock entity at that position and tell it that entity move to tile in case it needs to put any pressure plates down. Okay, and if distance remaining is not 0, then just subtract 1 from that. Count down until it hits 0. Okay, yeah, and that's all the core game logic, right? I think I covered everything relevant. So we saw everything in Entity Player. It's so nice and compact. It's kind of complicated and tangled in places, but like there's really not that much to it. Just a few pages. Like it all can fit in my head at the same time to understand what it does. I like this. I'm really happy with the core logic of this game. Was there anything here that I did not cover? Entity bump tile, entity moved to tile, entity moved from tile, toggle red blue switch, toggle elements. No, that's the whole thing. Okay, and can I call this complete now? Is there anything else in the code that I want to actually go over? I think the one thing I did not talk about was the pause menu. This was something that had to be invented from scratch for Throw Rock, and it was a big pain. I spent like the better part of a day on this whole thing. And honestly, I don't think it's that interesting. I'll scroll through the files real quick, and I guess if you're curious how it works, you can pause and look at it. So, okay, if I get a bunch of feedback on this video from people saying they really, really want to see in detail how the like control configuration screen works, because that one has some complicated logic. Oh, this part actually wasn't invented for Throw Rock. This was copied from Water Tower Classic because I had this code handy and it still more or less worked. So this has all the same strengths and weaknesses of that system. Yeah, there are nuances here that I could go through, but I'd just as soon not because this is a part of the code I don't really enjoy. And I don't think it needs to be really covered in this. But yeah, anyway, if anybody's super curious about it, I could do a little bonus addendum video. But at the same time, I'd be happy to just move on with what's happening here. Yeah, this is just like a bunch of drawing code. Oh, this is outdated. This looks completely different now that I've changed my rendering system. But that's what it looked like when Throw Rock was written. And that doesn't mean anything to anyone except me. Yeah, okay, so main section just draws those strings and the little pointer and stuff. Yeah, so this is as thoroughly as I feel like going through this. There's a separate reset save thingy, just logic for processing all the inputs and what that does. Right, all the settings, has all those items, toggles the preference values and saves the preferences and stuff. Oh. Yeah, if you turned off the music and you go to the music volume setting, you'd want to hear it so you could hear what you're doing. That would be nice. Or sorry, whether you've turned off the music or not, it stops in the pause screen. So right now, to find out what the number means, you'd have to just... So I don't like play a sound when I change the sound volume, do I? It's easier to go here than parse through the code. No. So you just have to try that, like... Pick a value, try it out, see if it's comfortable. Yeah, this should play a sound effect. While pointed at this, it should continue playing the music so you can hear exactly what's happening. That should happen. That would be a future improvement for me to make. Right, yeah, so here's actually doing the actions, all the toggles and stuff. Reset save. How to draw the checkbox, and then the strings themselves. Right, draw checkbox for all the ones that have them. Yeah, this code's not very pretty. and I didn't enjoy writing it, but I did enjoy the result. Okay, yeah, so I think that is sufficiently covered basically everything in Throw Rock. Okay, cool. I can finally wrap up the series here. Yeah, so been doing a bunch of programming and other stuff, but it's just this is the only thing I've talked about so far. So yeah, gonna have plenty of exciting stuff to talk about in the future of my whatever this is. These little videos that I do talking about things that I've been writing. But yeah, I think we can put Throw Rock to bed and be happy with how that turned out. Yeah, still super proud of this project. Very glad it came together the way that it did. And I'll see you sometime later for something else.